Good afternoon. George Hepworth, Grover Park Consulting. Let's talk about SQL Server security. SQL Server security is a broad subject, and I can only talk about one narrow aspect of it today. I'm going to focus on SQL Server authentication from an access front end to a SQL Server database without saving user credentials in the connection string for the linked tables in that ACCDB. Before I start, I want to remind you, although the method I'm going to illustrate in this video is more secure than it would be to store the user ID and password in the connection string, no method, not even this one, is 100% secure. At the end of this video, in fact, you'll learn how to retrieve the user ID and password from a cached connection in the active session, even though we never store the user ID or password in those tables connection strings. Let's find out how this is all going to work. The method I'm going to explain and illustrate is based on concepts from this article that Access MVP Ben Clothier wrote back in 2011. In this article, he discussed the problem of saving passwords in the connection string for linked tables. And he went on to explain some of the problems and how to avoid them. In that article, he talked about the interesting fact that Access, once it opens an ODBC connection, caches that connection. That connection remains valid during the session. This works even if you close the current ACCDB, open a different one, close it, and come back. And I'll demonstrate that. That means we only have to make one connection one time with a valid connection string, and then we can reuse that connection string from the cache as long as we want to work with that. I've already opened my sample database showing some random tables that I added to a back-end database on the local SQL Server. I'll start by showing the connection information for each of these tables. This comes from the MSys objects table. Table, the foreign name in the SQL Server database. This is what exists for the connection string for this table in this Access database. This is a generic version of a connection string. Notice that the order of the elements is not typically what you would expect to see. We would normally see ODBC followed by the driver, followed by the server, followed by the database. The other elements would be after that. The exact order is not important except for the ODBC, which has to be at the front. For this process to work, the only three elements that we actually need are the driver, the name of the server, and the name of the database. And in this case, because of the server I'm connecting to, I have to use encrypt equals yes and trust server certificate is yes. That's kind of outside the scope of what we're talking about, but these are required for this particular instance. The important point is that there is no user ID or password in any of these generic strings. Let's see what happens when we try to open a query. This is a pass-through query. It opens the login dialog because it does not yet have a user ID or password. If I try to open any of the tables, we have the same thing. I have code in this module which will establish my connection, cache it, and then it will be available. I have this little macro which does nothing other than run that code. I'll run it, close this to get it out of the way, test the connection, and this time it opens, showing me records from the city table. I can open any of the other tables. They all work now. They are all connecting with that cached connection because as you can see, it is still the same generic connection string in that table as we had originally. And again, to repeat, the required elements being the driver, the server, and the database for this to work. Let's look at the code which makes that happen. I have a function called initial connection cache. To make it possible to use this without ever exposing our username and password to a user, we created constants in the VBA specifying the username and password required for this server and database. If I password protect this VBA module, these will be hidden from the user. If I create an ACCDE version of this database, they will be hidden from the user. Well, that does protect the username and password from your average user. It's not foolproof, and we'll see why in a few minutes. One of the reasons why it's not the case in a few minutes. How does the initial connection cache work? We pull our values from our constants, and you can, again, set this up so that each ACCDB you use has different constants here. Pass in the ODBC, the driver, server database, and so on, all the elements that are needed for a successful connection, including the user ID and password. Then we create a temporary query def. We give it the connection string we just created. We tell it not to return records. We don't want to throw any records on the screen for the user to see. The SQL string we pass is to simply select options. We execute the query def. If it is successful, we just come to the next step. We can tell our code, okay, that worked. Our initial connection cache is true. If it fails, we get a silent failure. On the way out, we delete that temporary query def, close everything down, and leave. That's sufficient to establish a connection which is then cached. So even though the passwords and the tables do not have a complete connection string, they are still able to open and work during this session. If I close this ACCDB, open a different one, this is the database we'll use in the last part of our demonstration. For now, let's close it again and reopen our demo. We opened the demo, ran our code to create the cached connection string, closed it, opened a different ACCDB, closed it, and reopened it. The cached connection string should still be available because Access itself did not close. And there we opened our table again, even though we had the ACCDB open, closed it, opened a different ACCDB, closed it, and reopened it. That cached connection string remained available throughout the session. That sort of concludes this part of the demo. If you like what you've seen so far, go over, hit the subscribe button, hit the like button, let me know that you appreciate this kind of content. The next thing I want to do is demonstrate a problem. When I was discussing this approach, this method in an online forum, one of the other participants jumped in and pointed out that even though we can't see the connection strings in this ACCDB, it's possible to retrieve that cached connection string. And that's what I'm going to demo next. The first thing I have to do is close Access to clear out our connection string from memory. I've closed and reopened Access so that the cached connection is lost. We'll verify that we no longer have an active cached connection by trying to open this query, which opened on my other monitor. And as you can see, it's now asking for the login credentials again. I'm going to open a second ACCDB. Joseph Putzel at Access World Forums, I hope I'm pronouncing his last name correctly, provided this Access ACCDB to demonstrate how you can actually retrieve the cached connection string from a second ACCDB after that initial connection has been established and put into the cache. First, I have to point it at my demo database. His code retrieves a list of all the tables in that database, and you'll recognize these from our previous discussion. We'll select one and get the connection string from it. As you can see now, it's returning the generic connection string that I have put into all of my table connections. The second and third controls have not yet been filled out, and that is because off screen here, again on my second monitor, the server login dialog box popped up when it tried to connect to the server through this method. If I cancel it out, I get a second attempt, cancel this out. Now it's able to complete this line, or this control, placing the generic connection string again here. I'll go and bring our original sample database back, demonstrate that it is not able to open the connection because of the lack of a cached connection string. I'll run my query, establish the connection string, and now it will open. If I go back here, and from experience I need to reset here, select table animal again, get the connection string. This time it went more quickly. Obviously it didn't have to open the login dialog. It pulled back the original generic connection string. It pulled back the one that I created in VBA in my sample database, moving the driver into the first spot after ODBC, database and server, replaced the app name with one specific to this application, included the user ID and password, and I added code of my own to his code to parse out just the user ID and password. With this very simple method, a knowledgeable and determined developer, I'm hesitating, but using the word hacker seems appropriate, can bypass your attempt at security and retrieve the user information, the user ID and password information from the cached connection string in the source database, whether it's an ACCDB or an ACCDE. I'll open the ACCDE version, demonstrate that the connection string is not saved, run my macro, check again, and now the connection string is cached. Verify that we can't see the connection information in the VBA because we're working with an ACCDE. I will reopen the password reader. This time I will point it at the ACCDE version. Get the list of tables, get the connection string, and this time I have retrieved the user ID and password from the ACCDE. To sum up, although it is measurably more secure to create an ACCDE, I think what we've demonstrated is that although you can create a more secure version of your application, they're not all the way to the end of the scale. If you think of this as a meter from no security to 100% security, we've moved the needle from 0 to 50%, 60%, 70%, something like that. But we've still not reached full 100% security. A determined person, and I will use the term hacker because you would not expect a regular user, someone who's using your application day by day to get their work done, you would not expect them to go to this length to create a second database, copy this code in, run it just to retrieve the credentials in order to do something nefarious. It would have to be someone with nefarious intentions. However, it's important to remember that you have not yet created that 100% security. I've debated whether or not I was going to share Joseph's code. I finally decided against it. We are, after all, talking about security. I just don't see any reason to make it easier for people. If you do not store the user ID and password in the connection string and use an encrypted or password-protected VBA module or ACDCDE, you've moved the meter towards more secure. As long as you keep in mind that you have not moved the needle all the way over to 100%, you are better off than you were before. With that, I'll wrap it up for today. If you like what you saw, hit the like button. Give me that feedback that keeps me going. Subscribe to my channel. I'll see you next time.